All right, finding the probability of a disjoint union. So this is no longer an and statement. You don't need something to happen and something else to happen. This is not an intersection, but rather it's kind of an or statement. Either thing could happen and it would satisfy the condition of the event that you're interested in. Now let's remind ourselves of what the equation says. The probability of A or B is the probability of A plus the probability of B if it's a disjoint intersection. So if A and B don't have any overlap. Let's work through here. The first question, from a standard deck of cards, the probability of drawing a card suited hearts can be thought of as a disjoint union. The probability of hearts can be thought of as, well, you could get a numbered hearts card, or you could get, in fact, let me do this. Or how else can we break down hearts? So it's either a numbered hearts card or a face hearts card, right? And there's no overlap there, right? There are no numbered and face cards. So this is probability of numbered red plus the probability of face red. There are, how many numbered red cards are there? There's 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 9. The probability of a red face, there's 4 out of the 52. So there's 13 out of the 52, right? Because we were looking at the event of a hearts card, and there's 13 hearts out of the 52. And there's several different ways to break up these problems. You can think of hearts as being a single card at a time. Like you could get a 2 of hearts, and then you could get a 3 of hearts, right? And just add up all the individual cards until you get to the king of hearts, or maybe the ace, whichever you decide is on top, right? But once you add up all those individual cards, you see that you still get the same thing. There's 13 of those, and each one has a probability of 1 out of 52. The second question, what is the probability of rolling a 2 or a 3 on a 6-sided die? So on one roll of the die, the probability of 2 or 3. So again, there's no overlap here. It can't be a 2 and a 3. So because there's no overlap, I can add their probabilities. And each one occurs with a probability of 1/6 because they both represent 1 out of the 6 options on the die. This is 2/6 or 1/3. Right, you could have also gotten here by just counting events and thinking of it as a simple probability question. You're looking for a 2 or a 3. That's 2 options out of the 6. So again, this concept of maybe just follow your intuition instead of listening to the equation. But of course, you can always depend on the equation if your intuition doesn't have a direction. Let's work on number 3. The probability of rolling an even or an odd number on a 6-sided die. So probability of even or odd. So there is no overlap here. You can't be an even and an odd number. So probability of even plus probability of odd. How many evens are there on a 6-sided die? Not the 1, but the 2, the 4, the 6. How many odd numbers? The 1, the 3, the 5. I get 6/6 or 1, which of course I do because that's the size of my omega, right? The only possible outcome on a 6-sided die, or really any sided die, the number is going to be even or it's going to be odd. So of course you have 100% probability.